Hey guys, welcome back. Last time we graphed sine and cosine, so today let's graph their reciprocals, cosecant and secant. So I would pause, see if you can graph it, and then come back and check. What I like to do first is I don't really think in terms of secant values. I think in terms of the reciprocal setup, right? So 1 over sine is the way I'm going to think about cosecant values as I input angles. So maybe I'll draw a little unit circle to help me stay organized. All right, let's start with 0. If I put in a 0, 0 degrees or 0 radians, well, what's 1 over the sine of 0? That's 0. That's not good. 1 over 0, bad. What's that in our graph? I'm going to use a different color and put in a vertical asymptote, right? Divide by 0, we can't have that. That's our vertical asymptote. All right, let's move along. Let's put in pi over 4 here. That's in between 0 and pi over 2. So I get 1 over the sine of pi over 4. Sorry for how sloppy this is. Just getting used to my pen again. Well, what's that? Both x and y are root 2 over 2. So I have 1 over root 2 over 2. That looks kind of weird. Let's get rid of this denominator here by multiplying by its reciprocal. So instead it's 1 times 2 over root 2. And let's rationalize. Let's multiply by root 2 top and bottom. Well, 2 times root 2 is going to be 2 root 2. Root 2 times root 2 is 2. Oh, how nice. These cancel, and I get root 2. And if you remember in our first video, when we graphed sine and cosine for graphing videos, I said it's really nice if you could remember two things. That root 2 is about 1.4, and that root 3 is about 1.7. And this one's, I guess, a little easier to remember. If you think of square root of 4 is 2, so root 3 must be less, a little less. But for today, we're going to need this 1.4 number. So approximately 1.4. So at pi over 4, I'm approximately at 1.4, which, I don't know, maybe that's about there. All right, let's keep going around. If I put in pi over 2, I'm up at pi over 2. Well, 1 over the sine of, come on, why am I having trouble writing sine? Sine of pi over 2. I am at 1, a y value of 1, right? So 1 over 1, all right, I'm at 1. So at pi over 2, I'm at 1. Let's keep going. 3 pi over 4. All right, 3 pi over 4. Let's see. Anything different than my last answer? No, right? Both, x and y are root 2 over 2. And if I did the same workout, 1 over root 2 over 2, and I did all my multiplying, I get that 1.4 number again, that root 2. Okay, let's put in pi. All right, sine of pi. So let's see, what's 1 over the sine of pi? Oh, well, I get 1 over, what's the y value there? 0. Uh-oh, bad. That's another asymptote, right? So I have a vertical asymptote at pi. Okay. Well, this doesn't really give me a nice picture. Like, is it, I don't know, lightning bolts in here? What is this? Let's put in a couple more, and we have a couple more angles that are near and dear to our heart. So let's put in pi over 6. Maybe that's about there. And let's also put in pi over 3, which is, I don't know, maybe about here. All right, let's do one at a time. So 1 over the sine of pi over 6. All right, and maybe we'll draw a new unit circle over here. Let's see, pi over 6, 30 degrees over here. And what's our y value there? That's the shorter side. That's a half, right? So my y value at pi over 6 is a half, so I have 1 over a half. What happens? Flip, right? Times 2 over 1, I have 2. So at pi over 6, I'm at 2. Okay, where's that? That's about here. No, that is there. And how about if I put in pi over 3? Well, if I put in pi over 3, now I'm up here. Now my y is the larger side, right? So that's that root 3 over 2. So 1 over your root 3 over 2. Let's flip and multiply, right? Times 2 over 3. I don't like this. Let's rationalize. Root 3 times root 3. All right, 2 root 3 over 3. Well, what's this thing? Well, let's go back to the two numbers I totally remember. If you have 1.7 and 1.8. Let's divide by 2. You get about 0.9 for root 3 over 2. Not helping us here. How about root 3 divided by 3? Well, if we consider this 1.8 or 18 divided by 3 is going to be 6, or 0.6 in this case. All right, that's helpful. Let's multiply by 2. Oops, I lost my little division bar here. 0.6 times 2 1.2, right? So this is about 1.2, let's call it. All right, so I have root 3, I'm at 1.2. Where's that? Somewhere over here. All right. Well, if I did these same values and, convince yourself that it's true, but if I went to 2 pi over 3, right, I'm going to get these same values as I did before because we're talking about y values, right? I'm going to get this same number. And same thing if I did 5 pi over 6, right, or 150 degrees. I'm going to get that same two numbers of the 1.2 and the 2, right? So I get this shape for cosecant of this kind of looking cup-like thing. I think about them as cups. Wow, I'm the most horrible tracer in the world, but that's an idea of what it looks like, right? And it follows our vertical asymptotes. All right, let's continue along. Let's put in, what's this, pi over 4? Let's put in 5 pi over 4. Well, if I put in 5 pi over 4, so this was 3 pi over 4, now I'm at 5 pi over 4. What's the difference? I still am going to get these numbers, right, this root 2, but what is it this time? Well, it's negative root 2 over 2 was your y value down here, right, because we're talking about sine, right, your y values. So this time it's going to be a negative 1.4. So let's put that in. Negative 1.4 is about here, right? Let's put in 3 pi over 2. Well, 3 pi over 2 is down here. What's the sine value down there? Negative 1 this time, right? So 1 divided by negative 1 is going to give us negative 1. And how about, you could probably guess what 7 pi over 4 is going to give you, right? If I continue the 7 pi over 4, well, you get this same number again, but again, it's a y value, so it's negative, right? 1 divided by negative root 2 over 2 is going to simplify to this negative root 2, and again, about 1.4, right? Negative 1.4. And if you wanted to, and again, I convince yourself if you need more convincing, right? Put in those multiples of 30 degrees and the multiples of 60 degrees, and you're going to get that same shape out again, where you get 2 over here and you get 1.2 over here, and you get that same picture, but just upside down this time. What do you think you get at 2 pi? It's pretty fast. If I go back to 2 pi, or 0, right, what's the sign at 0? It's 0, right? 1 divided by 0, that's bad. Every multiple, convince yourselves also of this, every multiple of 2 pi is going to be, of pi is going to have a vertical asymptote, right? If we went to negative pi, well, let's see, negative pi is just this direction. What's the sign value there? Again, it's 0, right? 1 divided by 0, I get this vertical asymptote. So I get a vertical asymptote every multiple of pi. And I'm going to get this same picture. And again, maybe let's put in 2 more numbers. Let's put in pi over 2, negative pi over 2, and let's put in 3 pi over 2. Well, negative pi over 2, if I go down to negative pi over 2 over here, maybe I should change it back to blue since I had that for my asymptotes. Well, my sign value is negative 1, right? 1 over negative 1 gives me negative 1, right? How about if I put in 3 pi over 2, negative 3 pi over 2? Well, then I come up all the way up here. I'm at 1, right? 1 divided by 1 is 1. And I get this same shape that I got earlier. And you'll see they rotate from positive to negative. And over here, right, it's back to the positive version. And again, if you need more convincing, plug in as many points until you say, oh yeah, it is just going to repeat this forever and ever. And maybe before we do secant, what's the domain and range? Well, the domain, maybe we'll do that in a different color too. My domain is going to be, what numbers can I put in? Well, I can put in any numbers except, right? I can put in all the reals except, and maybe I'll say except x can't equal. Maybe it's better to write it that way. Again, like I said in previous videos, write it the way your teacher wants you to, right? All reals, but x can't equal, well, it can't equal 0, and it can't equal pi or 2 pi, so multiples of pi. So one way I could write that, pi times n, right? If I had 0, I'm on 0, it can't be that. If I have 1 for n, well, I'm at pi, it can't be there. 2 pi, right? So this is a way to write domain. And your range, what numbers can I get out? I can get any y value. I have any y value except this in between. So I guess we could write it as I can go from any negative big number, right, all the way down here, all the way up to negative 1, right? I can go to negative 1. And I can have, I can skip everything and start off at 1, right? I can have 1, and I can go up to the really big numbers, right? So I just can't have in between -1 and 1. All right, so that's what cosecant looks like. One thing I did want to show you, it's kind of cool, I think. Here's sine from what we graphed last time. Oops, put my drag around here. Let's bring this on up. Let's bring this up here. And what happens when we overlay these two? Let's see, where's my axis? Here we are. Wow, interesting. So it looks like I took my sine curve and I kind of, each of those like humps and valleys, it looks like I flipped them over and I made cosecant, right? So once you have this pattern in your head, you can actually graph cosecant a lot faster because you're like, oh, once you see how it's related to sine, visually it looks kind of nice and you're just kind of taking those humps and flipping them over if you would. All right, cool. All right, let's quickly do secant. I'll go a little faster this time because you kind of have an idea of how to graph these. Again, pause yours, try to graph it without me and see what you get. All right, secant. Maybe I'll change it to green. I don't know secant values, but I certainly know my cosine values, so I like to write it this way. All right, let's plug some in. Start at 0. Draw a unit circle. All right, well, at 0, what is my x value now? Well, it's at 1. So 1 over 1, I'm just at 1. Okay, so at 0 radians, I'm at 1. How about if I go up to pi over 4? Well, pi over 4, that's that root 2 over 2. So 1 over root 2 over 2, and I'm not going to do this out again. We just did all the work up there. That gets us out once we do all our reciprocal work there. I get root 2, which again we said was approximately 1.4. All right, 1.4. How about if I go to pi over 2? Well, 1 over the cosine of pi over 2 equals, all right, a pi over 2 cosine value is 0. 1 over 0, bad, right? This is going to be our vertical asymptote. All right, well, that doesn't help. Let's go back this way, maybe get a better picture because we can't cross our vertical asymptote here. Let's go to negative pi over 4. Well, if I go to negative pi over 4, these are x values, so in the first and fourth quadrant, it's still positive, and I get that same root 2 over 2 route, right? So 1 over root 2 over 2, I do the same work, I get 1.4. And you might notice this looks starting to look very similar to what we just did with cosecant, and it should because we saw sine and cosine look pretty similar. Let's put in negative pi over 2. If I go down to negative pi over 2, where am I at again? A bad place, right? X value is 0. I get 1 divided by 0, and I end up with an asymptote, right? And this is going to happen repeatedly, just like with cosecant, right? If I go up to, this was negative pi over 2. If I keep going around to negative 3 pi over 2, I get that divide by 0 again, right? Or the other direction, if I was at pi over 2 and I keep going along to pi over 2, if I go to positive 3 pi over 2, I get divided by 0 again, right? And maybe I should, hey, keep the colors here, right? And again, like we said, 3 pi over 2, I get another asymptote. And so this is going to look very similar to cosecant, right? So I'm going to get that same cup. And if you want, again, I'd encourage you, put in pi over 6, put in pi over 3, right? 30 and 60. You're going to get that same approximately 1.2 and 2, right? And if you did it with the negative versions. And so just to save time, and you might be like, okay, I get it, that's enough. That's what it looks like, right? Put in pi. If I put in pi, well, what's the cosine of pi? Well, that's -1, right? 1 over -1 gives me -1. So I'm down here now, right? And if I continue along, well, how about 2 pi? If I come back to the beginning all the way around at 2 pi, well, it's 1, right? 1 divided by 1 is 1. And you're going to get these same shapes right down here. You would get out the 1.4s again, and you would get that same cup, right? It rotates just like with cosecant. I would get 1.4 again over here, right? And that continues along. That goes up. If you put in negative pi, well, if I went negative pi direction, I'm at -1 again, right? 1 divided by -1 is -1. The 1.4s again at those multiples of pi over 4, right? And this repeats and repeats. If you put in -2 pi, you're going to get these same values, right? And so I get something that looks, right, similar to that. Very similar to cosecant. So are the the domain and the range, right? Let's briefly write those out. Domain, all right, what x values can I put in? Well, I can put in any real number as long as it's not equal to, as long as it's not on these pi over 2. So what would that be? I can't put in pi over 2. All right. And I can't do pi over 2n because if I put in a 0, I'd be saying I was here. So if I start at pi over 2 being bad, well, how much to get to the next bad place? Well, that's a pi, right? Distance of pi, right? If these are fourths, 1/4, 2/4, 3/4, 4/4, right? Pi distance. So plus any multiple of pi again, right? Can't be here and can't be here or back here, so on and so forth. So that's your domain. You can put in any x value, right? Any angle except for those. And then your range, exactly the same, right, as sine, right? As cosecant, right? I can go anywhere from the negatives, right? I can get out, I'm talking about my range. My output can be any super large negative number because these are going to go down forever, right? All the way up to -1. And then I can also I can start to get outputs starting with 1, right, all the way up to any big number that I want, all the way up that way, right? These will go on up to infinity and beyond. And just to do the same thing I did with cosecant, if I take our good old cosine graph here that we did last time and I bring him on up, well, look what happens, just like with cosecant, right? It looks like I took those humps and valleys and I kind of flipped them over, right? So it's also a nice kind of visual picture to have if you're trying to graph on a quiz or something, secant or cosecant quickly, you have an idea of, oh, that's what they look like. All right, well, I hope this helped. Again, make sure you can graph them without doing what I do, and then you'll be in a good spot to efficiently graph these when you need to. Hope this helped. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples, or if you want another topic to be covered.